After discussing linear polynomials in one variable and quadratic polynomials in one variable, the video links of the tutorials are given in the description box below. Please watch them. So after discussing them, let's talk about cubic polynomials in one variable. Here we have three algebraic expressions. And if you look at this algebraic expression, then it is x cubed minus x squared minus x and minus 1. Now this is a polynomial and it is a cubic polynomial. It's a cubic polynomial. And why? Because its degree is 3. Why? Because it has 4 terms, x cubed minus x squared minus x and minus 1. It has 4 terms. This first term contains a power of x that has an exponent that is the greatest exponent of these three, x cubed minus x squared and minus x. This is 3, which is greater than 2, which is greater than 1. Therefore, its degree is 3. It's a cubic polynomial. In this case, you have 1 by square root of 5 multiplied by x cubed minus 1 by square root of 5. Now, clearly it has 2 terms. The 2 terms are this term and this term. These 2 terms. Now, this first term contains the variable x. The power of x has the exponent 3 that makes it a cubic polynomial. That makes it a cubic polynomial because its degree is 3. What about this one? Well, this algebraic expression is not a polynomial. Therefore, there is no point of talking about whether it's a cubic or quadratic or whatever. And why it's not a polynomial? Because this x cubed is actually, we are taking the 5th root of x cubed, and the 5th root of x cubed means what? This is x 3 by 5, right? So this x 3 by 5 has the exponent 3 by 5. Now 3 by 5 is not a whole number. It's not a whole number. So since it is not a whole number, that's why this is not a polynomial. It's not a polynomial. This is an algebraic expression, but it's not a polynomial. Therefore, this is not a cubic polynomial, nor a quadratic, nor a linear. Okay. Now, we can express a cubic polynomial in one variable by writing down this: ax cubed plus bx squared plus cx plus d, where a, b, c and d are constants and a cannot be equal to 0. So first let's check these 2 points. First let's walk through these 2 points. It's completely similar to what we discussed in the case of linear polynomials in one variable and quadratic polynomials in one variable. Please watch those video tutorials. This particular thing will get completely clear to you. Okay, so what's happening here is, like, if you look at these examples, you have px is equal to x cubed plus 7x squared minus 10x minus 5. Now in this polynomial, you have 4 terms. This is 1, this is 2, this is 3, and this is 4. It's a cubic polynomial because the highest degree is, the degree is 3. In this cubic polynomial, x cubed means what? It's actually 1x cubed. So here 1 is a, 7 is b, minus 10 is c, and minus 5 is d. A is 1, b is 7, c is minus 10, d is minus 5. That's what it's saying. A, b, c and d are constants. Okay. Now, the next point is a cannot be equal to 0. Now think, what happens if here at the place of 1 it was 0? What would happen? If it were 0, this would become 0 multiplied by x cubed, and then rest will be same, that is 7x squared minus 10x and minus 5 and all. So let's write 7x squared. So if this a squared, this a becomes 0, that is 0 multiplied by x cubed. Now this this first term becomes 0. It's actually, this polynomial becomes 7x squared minus 10x minus 5. It's not a cubic polynomial anymore. It is a quadratic polynomial. And why? Because now it's x squared. This is the power of x which has the highest exponent of 2. That makes it a quadratic polynomial. Therefore, your a cannot be equal to 0. Now, if you are thinking that can b be 0, can c be 0, and can d be 0? Yes, they all can be 0. They all can be 0. Either one of them, two of them, or all can be 0. I'll explain you. This again is a cubic polynomial. It has 3 terms: square root of 7x cubed plus root 5 and square root of 5x squared and minus 10. These are 3 terms, a cubic polynomial. And in this case, square root of 7 is a, square root of 5 is b, and minus 10 is c. Now clearly here you don't have a term which contains the variable x only, that is x having the exponent 1. In this case it was cubed, squared, then here it was 1, and then here it was simply a constant. Here you have cubed, squared, but you have a missing this term which contains the power of x whose exponent is 1. That's missing. So in this case you have a, you have b, you have c, but you don't have, this is d. I'm sorry, if you look at this one, this is actually d. You have this c missing here, right? Okay. What about this one? It has 2 terms. Square root of 3x cubed and 7x. It's a cubic polynomial. Yes, it's a cubic polynomial because this is x cubed. Okay, the highest exponent is 3 in these 2 terms. Okay, now this is a, and now this is, if you compare with this one, this is actually c. You have b and d missing, because if you compare with this expression, ax cubed plus bx squared plus cx plus d, here you don't have x squared expression, right? Here you don't have x squared term like in this case. So your b is 0, and then you have d is 0, because here you don't have any constant. Any constant. That means that it's actually what? Plus 0. Therefore your d is actually 0. A cannot be equal to 0. B can be 0. C can be 0. D can be 0. What about this one? Again, here you have 2 terms. 22x cubed and minus 10. It's a cubic polynomial because it is x cubed. The degree is 3. Here your a is 22. Now that term which contains x squared is missing. It means that b is equal to 0. That term which contains the power of x whose exponent is 1, that is missing. It means that your c is also 0. Minus 10 is what? D. So you have a, you have d, but b and c are missing. Here b and d were missing. What about this case? In this case, 1x cubed means what? That is 1x cubed. Sorry, x cubed means 1 multiplied by x cubed. So it has only one term, that is 1x cubed, and this is the constant a, right? That is a is equal to 1, but here you don't have the term which contains x squared. It means that b is equal to 0. Here you don't have the term which contains cx. It means that your c is equal to 0. Here you don't have d at constant. It means your d is 0. It only contains one term, that is 1x cubed. It means that a is equal to 1. B is 0. That's why you don't have this term. C is 0. That's why you don't have this term which has a power of x having the exponent 1. And d is 0. That's why you don't have any constant. So you can write it like this. So the point is that when it is written in the form of ax cubed plus bx squared plus cx plus d, a cannot be equal to 0. Otherwise, this will not be a cubic polynomial anymore. A cubic polynomial can have at most 4 terms, and that makes sense. It can have at most 4 terms, not more than that, as you can see from this example. First one, x cubed, x squared, x, and then you have a constant. You cannot have the 5th term. Like if someone says that What about this one? 7x raised to the power of 4 plus 5x raised to the power of 3 plus 2x squared plus x plus 1. Now this is not a cubic polynomial because here the degree is 4. It's a degree 4 polynomial, right? It's not a cubic polynomial. So what about this one? If someone might say that, hey, you know what, it's 7x cubed plus 10 minus 8x squared plus 2x cubed minus 2x plus 5 minus 4x. So if someone comes and says that here, you can see that the degree is 3 because this is the power of x which has the highest exponent of 3. Same thing here. So the degree is in this case 3. Completely agree. Degree is 3. So that person might say that, you know what, it has 1 term, 2 terms, 3 terms, 4 terms, 5 terms, 6 and 7 terms. No, it doesn't have 7 terms. Why? The concept of like and unlike terms. So in this case, this is 7x cubed. Then you have 2x cubed. These two are like terms, right? Then you have minus 8x squared. So this is the only term which contains x squared. So minus 8x squared. Then you have minus 2x and minus 4x. So plus minus 2x minus 4x. These two are like terms, so you'll add them together. Then you have 10, then you have plus 5. So 10 and 5. Now this becomes 9x cubed minus 8x squared minus 6x plus 15, right? So this is a polynomial, a cubic polynomial, which has 4 terms. It can have at most 4 terms, right? It can have only 1 term, like we saw in this case. Here it was just x cubed, right? It was only x cubed. So x cubed means what? It has only 1 term. In this case, it has only 2 terms. In this case, it has 3 terms. In this case, it has 3 terms. In this case, it has 4 terms. You can't have the 5th term. You can't have the 6th term, right? So this is about this was about cubic polynomials in one variable. In our next video tutorial, we'll talk about of a polynomial in one variable which has a degree n. How will we express that? Okay, how will we so we have learned how to express linear polynomials in one variable. We have learned how to express quadratic polynomials in one variable, about cubic polynomials in one variable. And next we'll talk about a polynomial which is of degree n, how to express that.